It's time for us to enjoy binomial distributions, example 4, part C. All right, we've already set it up. We've surveyed 15 people. We're interested in how many of those 15 people floss every day. The question mentions flossing, which we were told was 59% of our population, so that's considered success, and 41% would be the failure, Q. All right, so to me, it's a question of determining all the numbers over here from 0 to 15 that would satisfy the question. This says, what's the probability of those 15 people that at least 4 of them floss every day? So what's the probability that the number of people who floss every day out of 15, which could be anywhere from 0 to 15, what's the probability that that's at least 4? All right, so I come over here and I look at the range of numbers and I say, which one of those would be at least 4? And I hope you would agree. I think I'm able to tell from looking at your smiling faces that at least 4 would be anywhere from 4 all the way up to 15. So again, that would be the original question. At least 4 would be all the numbers from 4 to 15. Now, let's talk about what would be a math symbol for that. How would the variable have to relate to 4 if we're talking about at least 4? What math symbol do you guys think? How about greater than or equal to? Exactly. Mr. Sourdough is so proud of you. Greater than or equal to 4. That's right. That's 4 or more. Greater than or equal to 4. At least 4. Yes. All the way from 4 to 15. Good job. I'm very proud of you guys for hanging with me on this. All right, now, let's look at this from the point of view of a mathematician, a math detective, if you will. So let's think logically about this, shall we? So, one way that we could do this is if we want to find those probabilities for every number from 4 to 15, couldn't we perhaps set up all the probabilities for 4, crank that out, 5, crank that out, 6, crank that out, 7, crank that out, 8, crank it out, 9, crank it out, 10, 11, 12, 13, 14, 15, crank them out, add them together. Yes, that works. But no, we're smart, we're lazy, we're mathematicians. We say, you know what, I could do that, sounds like a party, but you know what, wouldn't it be less work to find the probabilities for 0, 1, 2, and 3? In other words, the opposite of the original question? I think that makes sense. Yes, elementary, my dear Watson. And wouldn't that total, since it's the opposite, the complement of the original question, wouldn't we want to take this total away from 1? I want to remind you that we know that if you calculate every single probability for every possible value of x, they have to add up to 1. Good idea. So let's do the complement, these numbers, and subtract it from 1. I like it. Good idea. Good job. Everybody give each other a high five. Or 10, or whatever. All right, or kick excitedly. I don't know. It's getting late in the day, can you tell? So anyway, 1 minus, right? Because we're going to take this total, subtract these, and it'll leave this. Less work, smart, all right? Now, this is going to be what? Probabilities for these 4 numbers. This entire total, therefore, I'm going to put it in a big old bracket to show that this needs to be totaled up before we subtract it from 1. And now we'll do the probabilities for those other numbers. Let's start with 0. I give you 15 people. You can choose 0 of them to floss. Flossing, I know I'm standing in the way. I'm sorry, I can't be invisible. But anyway, that's 0.59. I'm sure many of you wish I was. 0.59 to the 0, 0.41 to the 15th. That'd be nobody flosses and 15 do not. Plus, oh, let's check it off. That's 0, right? Plus, all right, 1. 15 people choose 1. Floss, 1. Do not floss. How many? 14. Yes. If 1 person flosses, 14 do not. There's 15 people in the group, right? 15 people that got surveyed. Oh, that'd be 1. Let's check it off. All right, how about 2? We got 15 people. You can choose 2 of them to floss. It's a combination because we don't care about the order. All right, how about 59% to the set. 2 people floss, right? Which means, let's see, if 2 of them floss, how many do not? 13! Yes! You guys are on fire. All right. And that would be the 2. All right. And then 3, we got 15, choose 3. And we would have floss, 3 people. And if 3 of those 15 people floss, how many of them do not? 12! Yes! Man, we're rocking. All right, so that would be that right there. That with this total, and the brackets are there to show that mathematically you have to add all that up before you take it away from 1. All right? And that's a lot of button pushing, but you know, we set the stage for that before spring break. And so, after doing all the math, and I understand we can discuss that if you want, although we're not here to talk about it, but I've had a lot of people in the past tell me that once they get the setup, they know what they're doing. So I just have to tell you that the final answer is something like 0.9975182. Let me double check that I'm looking at the right thing here. We're doing part C, and I believe that would be it. So there you go. You use logic to figure out whether to do the original question or whether to do the opposite, the complement. In this case, the complement was less work. Let's do it. Take it away from 1, and that'll be the question that we were asked. Sounds like a plan, huh? All right, so we'll be right back here pretty soon to do part D. Awesome.